Development of the Surveyor spacecraft began in 1961. Detailed design specifications were issued, and hardware was built and tested. In May 1963, a mock-up of Surveyor was for the first time mated with Centaur hardware. At the same time, the first functioning prototype of Surveyor was being assembled. Many test design difficulties had to be overcome before Surveyor's complex terminal descent through the lunar vacuum could be simulated on Earth. The descent test problems were solved, however, and the terminal descent system was repeatedly verified before the first mission. In July 1964, the Surveyor prototype went through a mission sequence test for the first time. The prototype was later subjected to many severe environmental performance tests, including several simulated transits to the moon under solar thermal vacuum conditions. While the prototype was being tested, SC-1, the first flight spacecraft, was assembled and began its own series of tests. In March 1966, SC-1 was shipped to Cape Kennedy from the Hughes Aircraft Company. After extensive pre-launch tests and preparations, SC-1 was transported to the launch pad. On May 30, 1966, Surveyor was launched on its historic journey to the moon. On June 2, 1966, Surveyor-1 soft-landed on the moon. It returned over 11,000 photos and a large volume of telemeter data. In September 1966, SC-2 was launched. Unfortunately, a malfunction occurred during mid-course. After repeated attempts to correct the problem, the retro rocket was fired, and all contact with the spacecraft was lost 2 seconds later. Because its radar altimeter and Doppler velocity sensor lost lock, Surveyor-3's vernier engines did not cut off, and the spacecraft made 3 soft landings before coming to rest about halfway down the side of a crater 650 feet in diameter and 50 feet deep. Surveyor-3 returned over 6,000 photos, including this one, showing several features recognizable in lunar orbiter photos of the same area. Surveyor-3 also sent the first surface sampler data. SC-4 was launched in July 1967. Unfortunately, all contact was lost just before touchdown. Which of several possible failure modes occurred had not been determined. Though Surveyor-5 did not carry a surface sampler, footpad number 2 dug its own trench as the spacecraft skidded down into a small crater. The lunar soil appeared almost identical to that seen at the previous landing sites. Surveyor-5 carried an alpha scattering instrument. Analysis of that instrument's findings indicated that the composition of the lunar surface material is close to that of common terrestrial basalt. The magnetic materials test results agreed with that analysis. Surveyor-6's scientific payload duplicated that of 5, and its analysis of the lunar material also duplicated that found by 5, 460 miles east. Surveyor-6 returned over 30,000 photos, more than all 3 previously successful flights together. Since potential Apollo landing sites had been adequately surveyed, SC-7 was assigned a scientific mission in an area just north of the crater Tycho. The spacecraft landed safely in the rockiest area yet encountered by Surveyor and supplied a vast amount of new data. The story of Surveyor is measured in more than just 5 successful missions. Surveyor accomplished what it set out to do. For the Apollo mission, Surveyor demonstrated conclusively that the moon, made up at least in part of materials comparable to those on Earth, can support man and his machines. The Surveyor spacecraft probed the physical and chemical nature of the moon and transmitted thousands of photographs. To land a man on the moon remains a national goal. Surveyor has contributed immeasurably to achieving that goal.